Hi everybody, this is Happymath channel. In this video, we will continue with the anti-derivation. In this video, I want to detail the integrating of e power to h function. This is one of the most difficult function in the program about the calculus or integrating or anti-differentiation. Let me tell you about the basic formula about the derivative first. Derivative of the e power to h function will equal to e power to h times with dx. You should carefully about the single in the simple here. It is the time operation, multiple operation, and the inversely ways of the differentiation is the antiderivative or integrating e power to h times with dx will become to equal to d times d of e power to x. In the normal ways, you should see the antiderivative signal in this way. And let's remember this signal is opposite to this signal. So when two sides here nearby together, it will become to nothing or invisible. So this one will become to e power to h plus c. It is the antiderivative way. And when you want to calculate the integrating or anti-differentiation, you have to care about the number in this way and this way. But it is an advanced technique, so we will learn it later. Yeah, just forget about the let's just forget about the original function of the integrating e power to x. Let me make clear about this formula. When you take the e power to x times with dx, it means you have to change from the main function from the left of the dx becomes the right of the dx. So the formula have to change. The new formula is e power to x, and the main function from the outside of the dx will become to the inside of the dx. Yes, and in this formula you have that e power to x times with dx will be equal to d of e power to x function. The most important thing in this formula, you have to note that the number of this way of this position have to be equal to the number of this position. For example, when I got e power to 2x of d 2x, the function or the expression of this in this power number have to be equal to d of this number. So when you got that the two number here is equal together, it will become to the main function from the outside of the dx will become to the inside of the dx. It means e power to 2x will become to the right of the derivative. It will become to e power to 2x function. When this side stand nearby in this side, it will become to invisible, and you have to plus c at the end of the process. And let me clear about this in some example. And in this function, you got that the 3 times with e power to 3x times with dx. First, the constant number here is 3. So I can call it 3 is a scalar factor. And because it is a scalar factor, it doesn't make change about the process of this function. So I can change the position of the 3 from the outside. It become to the inside the dx. So from the dx, it becomes to the d of 3x. The number of this position equal to this position is the same. So I can change that d of e power to 3x in this way. And of course, when I take the integrate thing simple like this, here and here. So this is couple. It will become to nothing. So e power to 3x plus c in the end of the process, the integrating process. Okay, from now, this number is 5x, the power number is 5x, so the dx here only x, so I need 5. So when I change from the dx become to the d of 5x, it means I have to time with 5 in this position. So I want to unchain the main position or the main function of this one, so I have to divide by 5 because I have to time 5 in this way, and I have to divide by 5 in this way. Okay, so I can consider the 1 over 5 here is a constant number. Okay, and now the number of power number is the number of the of the derivative function. So I can change from the total function outside the derivative, I mean left of derivative, will become the inside of the derivative or in the right of the derivative. So 1 over 5 d of e power to 5x, and which become to the d of e power to 5x over 5. Yes, so in the test you will see this one and this one, and you will know about the final step in this process. Okay, I think you can understand this way. And now this is harder. You should understand the square root of something or n square of something is the power number, and the power number here is 1 over 2 because this one is a square root. So I can change from this one, it become to the e power to x power to 1 over 2 divided by x power to 1 over 2 times with dx. And of course you understand this one. And another way, when I got a power to 1 over a power to n, this means equal to a power to minus n. Okay, so this one is the x power to 1 over 2 in the denominator position, so I can change from this one equal to this one. Yes, this is the main function, and the power number of the e function, e power x function here is x power to 1 over 2. So how can I change from the x become to the x power 1 over 2? Look at this. I will move this function become from the outside of the derivative become to the inside of the derivative first, and this one will become to x power to minus 1 over 2 plus 1 divided by minus 1 over 2 plus 1. If you understand about this step, you should see the previous video about the anti-differentiation. I will you will take more clear about this function. And step this one will become to the x power 1. And now simplify this one. X power to minus 1 over 2 plus 1 is mean x power to 1 over 2, and divide by 1 over 2. Divide by 1 over 2 in this position is mean you have to time 2 in the scalar factor. Time with d of x 1 over 2. And now you can see that the position here is equal to this position. So final step, let's see. Okay, understand? From the another example in this video, I think you should practice by yourself first. by this way. You stop this video and you do it by yourself first. After that, you watch continue this my video to see the solution. Okay, and now in this one, this exercise, I want to change from the dx it have to become the 3x minus 2. So first one, I will change dx will become to the d of 3x first. You time with 3 here is, so you have to divide by 3. Yes, and you got the scalar factor is 1 over 3. E power to 3x minus 2. And now from the d of 3x, I will change the function derivative become to the 3x minus 2. And it doesn't make change outside the derivative because it is a constant number. So from this one, you see the formula in this way. So I move from the main function outside the derivative, it becomes the inside the derivative. It is d of e power to 3x minus 2. And in your test, you will see this symbol. And from this one, you will got that d of e power to 3x minus 2 divided by 3. So this one is cardboard, so it becomes the invisible. Plus C. Okay. Go on. The next one. First, I want to change dx have to become d of the minus x first. Time with minus 1, it means you have to divide by minus 1. Minus and minus, it becomes 2. And I plus c, and I plus 2 in the derivative function. And the number, the expression in this position, power number, equal to the position of the derivative. So take the main function inside, and you will got plus C. Okay, it's very easy, and go on. So from this function and this function, I will to moving from x from outside of the derivative become to the inside of the derivative, and I think you know how to do that. D of x 1 plus 1 divided by 1 plus 1. Okay, so in this one I have to 1 over 2 is a scalar factor. It's become move outside of the integrating. And d here is become to the h power to 2. From h power to 2, I change it to h power h squared plus 3. And the outside derivative will be unchanged because the plus 3 is a constant number. And from this one, the number here, the position, the equation of position will be equal to the equation of this position. So apply the integrating each power e power to h function, you will got and it will become the final function. Okay, understand? It's very easy. Okay, so last one. Moving on, h squared become the inside of the derivative is become to the h3 divided by 3. Divided by 3 here is cancelled in the 3 outside, so it equals to 1. H power to 3 plus 4 of d h power to 3 plus 4. the number is the same. So good for, and when I cancel integrating and the derivative, you have to add more constant number at the end of the process. Okay, so in this video, I hope you can understand about the integrating of the e power 2x function. This is not too difficult, but I think this the ways I give you in this video will be very easy to apply for another function of in the integrating topic. So thank you so much for watching video in this video, and if you like this video, please share or subscribe my channel. Thank you so much.